Hi, my name is Celeste Garcia, and I'm going to be explaining the project Equilibrium. So the first problem is A 5.00 moles of sulfur trioxide. So SO3 is placed into 5 liters reaction vessel and allowed to compose at 400 K according to reactions above. Once equilibrium is established, 3.5 mole of surface dioxide SO2 is present. Write an expression for equilibrium constant C for the reactions above. So the expression of equilibrium constant K that I chose was SO2 squared by 2, and then in brackets I have O2 all over SO2 squared 2. And the reason I chose this was because SO3 to squared to the second is on the before the reaction side, and the ones on the top are after the reaction. So you have to do that to find the expression. For the next part, you have to calculate it. So the initial molar mass of SO3. So what I did was 5.00 moles over 5.00 moles is equal to 1 mole, which is equal to SO3. So for part C, now we have to calculate the equilibrium constant Kc for this reaction. SO2 EQ is equal to 3 moles over 5 moles, which is equal to 0.600 moles. So 2x is equal to 0.60, and then x is equal to 0.3. So you have to do that, you have to find you have to do an ice table. So for SO2, we know that it's 1.00, and then for both on the right side of the arrows, it's going to be 0. So then for C, it's going to be negative 2x for SO2, and for the other ones, it's going to be plus x and x right here. And then for when we calculate it, E is going to be 0.400, this is going to be 0.600, and O2 is going to be 0.3. So then we're going to have to plug that back in to get SO3 equals negative 1, negative 2 times 0.60, which is equal to 0.40 m. And then we're going to use that the O2 EQ is equal to M3, and that's why we have them up here, because we're going to use them for knowledge. And then finally we have Kc is equal to SO2 over squared by 2, and then O2 all over SO3 squared 2, and that brings us to 0.60 squared by 2, 0.300 over 0.40 squared to 2, which is equal to 0.675. So now for part D, we have to calculate the equilibrium constant Kp for this reaction. So Kp is equal to ATM, so partial pressure times partial pressure. So we know that PV equals nRT, and we also know that we have to use P equals nRT over V. P equals M times RT. So for the first one, we have PSO2 is equal to 0.60 m. So we're going to do that, and so parentheses 0.0206 times 400, and then we have PO2, which is equal to 0.3 m, and then we have the same as the previous one. And then for PSO3, we have 0.4 m and the same constant, which is 0.0206 times 400. And then finally we have Kp is equal to 19.7 squared by 2 and 9.85 over 13.13 squared by 2, which will give us 22.2. For the next part, we have to do the reaction vessel above is cooled from 400 to 298 K. The mixture reestablished equilibrium with fewer moles of sulfur dioxide and oxygen gas at the new temperature. Is the forward reaction endothermic or exothermic? Justify your answer. So I think based on the evidence that it would be endothermic. The reason I think this is because as we can see, the temperature starts at 400 K and then drops to 298. So when it shifts, it causes it to go into reverse direction, which means there are more reactants than there are products. So part H. Part H is to determine whether the number of moles, SO3, will increase, decrease, or stay the same after each of the following disturbances. Justify each response. So I is the temperature of equilibrium mixture is decreased. So for that I answered because the temperature is endothermic, we can see a decrease in temperature that will cause the reaction. Because it is endothermic, it will favor SO3, which causes it to increase. And then for the second part, the volume of the reaction container increased. So the volume of the reaction container increased, which means the pressure decreased, because when volume goes up, the pressure decreases, which causes the reaction going forward to be thermodynamically more inclined to choose 2 moles of 3 moles of gas. So we can see that SO3 will decrease unlike when it is at equilibrium. So for the final part, and some would say the most fun, some not being me, in the different experiments, sulfur dioxide and oxygen gas were added to the reaction vessel at 400 K, and the following reaction occurred and equilibrium was established. So we have to calculate the equilibrium constant K for this reaction at 4K. So what you have to do is SO2 in gas plus 1 over 2 O2, and then we have the arrows for the reaction, SO3 grams. So we have that. So then you have Kc is equal to 1 over Kc squared by 1.5, which will equal 1 over 0.675 squared by 1.5. Thank you. I hope that was easy to understand and easy to follow.